Hello Year 8. Today we're moving on to surface area of prisms. Now, area is the amount of space that a two-dimensional shape takes up. But surface area is the area of all the faces of a prism added together. Now we have a formula for a couple of these types of shapes. And we have the formula for a cube. Now, a cube, all the faces are squares. Now, remember that the formula for a square is s squared. And there are 6 sides to a cube, which is why it is 6 times by s squared. The other formula we have today is a rectangular prism. Now, there are 6 faces on a rectangular prism, but there are a few different ones here. The one on each of the ends would be the same. The one on the sides would be the same. And the one on the top and the bottom would be the same. So that's why there's 2 lots of LB plus LH plus BH, the 3 different sized rectangles in that diagram. So need to memorize that formula there as well. A net is a two-dimensional representation of all the surfaces of a solid. It can be folded to form the solid. So below is the net of a rectangular prism and the final rectangular prism that it creates. To find the surface area, you can find the area of each face of the prism and add all of these answers together. Alternatively, you could think of the net and find the area of the net, like finding the area of composite shapes and adding all those rectangles together. Okay, so if we look at the examples, this first example just asks us to practice finding how many faces there are on the prisms. So this first prism here is a rectangular prism. So you'd have the big rectangle on the top and the bottom, 2 long skinny ones on each side here, and a shorter but skinny one on the front and the back. So altogether there would be 6 faces on that prism. The second one here for part B, this is called a triangular prism because you have a triangle on the front and the back. So there's 2 triangles. And then you would have 3 rectangles going around the middle. So that's a total of 5 faces for the triangular prism. So you need to be aware of how many faces there are so that you make sure that you don't miss any when calculating the surface area. So let's have a look at example 2. Calculate the surface area of these prisms. Now the first one is a cube. We have a formula for the surface area of a cube, and it is SA for surface area equals 6 lots of, or 6 times by s squared. And s is just the side length, which in this case is 3. So it's 6 times by 3 squared, and we can calculate that on our calculator as 54 centimeters squared. It's still squared because it's still area. Part B is a rectangular prism, and we have a formula for that. So it's 2 lots of LB plus LH plus BH. Again, I tend to use capital letters so that my L's don't look like 1s. Now, it doesn't matter if you get the order of these slightly wrong, as long as you have the 3 different sized rectangles in there when you substitute in. So the 2 is out the front. I'm going to start with this little rectangle on the front, which will be 12 times 4. Then I'm going to go to the long skinny one on the side, which will be 15 times 4. And then I'm going to go for the big one on the top and the bottom, which will be 15 times 12. Okay, as long as you have the 3 different ones there. So 2 times by 12 times 4 plus 15 times 4 plus 15 times 12. 576 centimeters squared. Okay, question 3 says calculate the surface area of the prism below. Now this is a triangular prism. We don't have a formula for this. We just have to add each of the shapes together. Now the net over here actually helps us see that there is 5 shapes here. 2 of them are the same, the 2 triangles are the same, but we have 3 different sized rectangles. So to find the surface area, I have to do it the long way and add all of those areas together. So surface area equals, I have got 2 triangles, so 2 lots of half base times height. Then I have 3 rectangles, so that's going to be L times B plus L times B plus L times B, 3 different rectangles. So let's start with the triangles. The base and the height of the triangle will be the 2 connected by that right angle, the 4 and the 9. So 2 times half times the base, which is 9, times the height, which is 4. Okay, now the first rectangle, I'm going to start here for this one. So that's going to be a base of 4.5 and a height or a breadth of 8.1. So 4.5 times 8.1. Okay, that's for that first rectangle. The second rectangle, it is going to have a length across the bottom here of 9 and a breadth of 8.1. So 9.0 or 9 times 8.1. Plus my third rectangle over here, which has a 7.2 length and an 8.1 height. So 7.2 times 8.1. And calculate. 2 times half times 9 times 4 plus 4.5 times 8.1 plus 9.0 times 8.1 plus 7.2 times 8.1. So 203.67. And the units are centimeters squared. Okay, so question 4. So another triangular prism to find the surface area of. This time we don't have the net to help us. But just like last time, we're going to have the 2 triangles, so 2 lots of half the base times the height, plus we have 3 rectangles. But for this one, the 3 rectangles are actually going to be all the same, because see how we have these little lines here? That means that the lengths of those rectangles are all the same, and the breadth back here going backwards to 7.5 is the same. So for this one, I could just do 3 lots of length times breadth, because the 3 rectangles are all the same size. So substituting into that formula, 2 times half times the base times the height. So the base is 4 and the height is 3.6 for the triangle, plus my 3 rectangles, which have a length of 7.5 and a breadth of, okay, this is the tricky part, I don't have a breadth, because the breadth needs to be, oh yes I do, sorry, it's this one down here, it's the 4 centimeters down here. So that line there, because that's 4, it means that these ones are all 4 here. All right, good. So we can just type that in. 2 times 0.5 times 4 times 3.6 plus 3 times 7.5 times 4 is 104.4 centimeters squared. And finally, this is our last question, question 5. A book 20 centimeters long, 15 centimeters wide, and 3 centimeters thick is covered in plastic wrap. Okay, so I'm just drawing a quick diagram here. So I'm going to say 20 centimeters long, 15 centimeters wide, and 3 centimeters thick is covered in plastic. What area of plastic is needed to cover 1,000 books? So if we do the surface area of one book, now we have a formula for the surface area of a rectangular prism. So it's LB plus LH plus BH. Subbing in will be 2 lots of 20 times 15 plus 20 times 3 plus 15 times 3. So that would be the amount of plastic required to cover one book. So it's 810 centimeters squared. But if I want 1,000 books, so therefore for 1,000 books, we would need to have that amount times by 1,000, which is 810,000 centimeters squared. Now to change from centimeters squared to meters squared, because it asked me up here to convert into meters squared, I would need to divide that by 100 squared. If you look back in your notes, you'll see that little conversion chart on how to convert from centimeters squared to meters squared. So on the calculator, if I divide that by 100 squared, that means that's 81 meters squared of plastic wrap that you would need to cover 1,000 books. And that's it.